So now we'll be solving question number 24 from phase 1, chapter called Forces and Laws of Motion. Exercise 1. Question number 24. Two balls of masses m each are hung side by side, two long threads. Each length of the thread is L. Now, if the distance between the upper end is R, then find the distance R dash between the center of the ball in terms of G. So this is the case here and here. These distances are given as R. If the balls will be completely independent of each other, they'll be hanging completely vertically. But in this case, they are not independent, they are together. So they will be experiencing the gravitational attractive force. So because of the gravitational attractive force, these forces, these balls basically will be nearby to each other. The distance, let's say this is R dash. That's what we have to calculate. The masses are same for each and every ball. And as you can see, the length is also same. This one and this one. So the system is symmetric. This system is symmetric. So whatever is happening with first system, the exactly same thing will be happening with the second system. Exactly same. What I'll do, I'll cut it into two parts from the midpoint. And I'll be solving for this system. I'll make the FBD and I'll be solving for this system. So I'll make the FBD of ball A. First ball, this one, first ball. So it's equilibrium, so acceleration will be 0. Now this ball is experiencing three forces. It is experiencing mg force downward. Mg is not depending upon the gravitation at all. It is experiencing the gravitational force sideways, and there is one tension is acting in this direction. If this angle is theta, this angle is also theta. These three forces it is experiencing, and acceleration is 0. The value of Fg will be equals to G m1, which is m, m2, which is again m divided by r square, distance between them. And distance between them is r dash. So r dash square. That's the gravitational force acting upon them. That comes out to be capital G m square upon r dash square. That's the gravitational force. So as you can see here, there are three forces. And we know like whenever we find the three forces, to save the calculation, we can go for the Lami's theorem. To save the calculation. So I'll go for the Lami's theorem. If I go for the Lami's theorem, it's pretty simple. The force divided by the opposite angle. So Lami's theorem will give us the tension, the force divided by the opposite two forces, angle between opposite two forces is 90. So sine of 90. So you take the force and you divide it by sine of angle between the opposite two forces. That will be same as other force, which is let's say mg divided by the other two forces, which are these, the angle. So this angle is going to be theta plus 90. Sine of theta plus 90. And that is equals to Fg, which is g m square upon r dash square divided by this angle, sine of this angle. So this is theta. So this is going to be pi minus theta. Sine pi minus theta. So as you can see, in this case, there are two variables. The theta is variable and r dash is variable. And the tension is also variable. So here. Okay. So what I'll do here, I can go for this or I can go for this basically. I'll be able to calculate the r dash. This is one way. And the second way basically can be the FBD. And FBD, as you can see in the question itself, I'm going to take the component. So this will be t cos theta and this will be t sin theta. Since the acceleration is 0, this t cos theta will be balancing mg and t sin theta will be balancing the sg. So you can say T cos theta is equals to mg and T sin theta equals to g m square upon r dash square. Now it comes to theta, so a little bit geometry we can use. You see, this distance. So this distance basically is r. This distance is r dash. So this distance you can write it as r minus r dash. So this distance is r minus r dash. And if you go for this triangle, in this triangle, the theta, you can define in terms of r and the r dash. Tan theta will be equals to perpendicular, which is r minus r dash divided by, let's not go for the sine, then let's go for the sine. I'll go for the sine. Sine theta will be perpendicular, which is r minus r dash divided by hypotenuse, which is n. This is the value. So actually, since I got the sine theta value in terms of r dash, I can use this or I can use this and I can get the value of r dash. So I'll use this one, this information. If I'm using this information, I'll be getting mg by g m square upon r dash square. If I take this here, this I'll take on this side. So sine 90 plus theta is is cos theta divided by sine pi minus theta is still sine theta, which is cot theta. We know the value of sine theta. From here, we can get the value of cot theta in terms of r dash and all. We'll replace it. So we'll get the single equation in terms of r dash, and this will be a quadratic equation. So by solving the quadratic equation, we will be able to solve the value of r dash. This question at this point basically is to improve your calculation. In this question, basically our calculation will be getting improved. It's a little lengthy question, so geometry is also used. Fourth method is also used. And the concepts of the gravitational is also used, multi-concept question. Okay, thank you.